Hey guys, welcome to Crown's Maths. In this video, we want to show an example of an algebra. So here is a nice example. We want to show that this is what an algebra. So this class is saying that there is a collection of a set A, which is a subset of R, such that either A or A complement is what? Finite. That is, for A to be inside this set, it is either that A or its complement must be what? Finite. Okay? So to show that this is an algebra, we need to show that it satisfies the three conditions: that the empty set must be in the algebra, that if we pick an A in the algebra, its complement must be also what? In the algebra. And if we pick any two sets, their finite union is what? In the algebra. So let's begin. Okay, now for the first part, let me write proof. Okay, for the first part, the empty set is in the what? Is in the algebra, since the empty set is what? A finite set, because we say that either A or its complement. If A is not finite, then its complement must be what? Finite. Now the empty set is a finite set. Why is an empty set a finite set? Because the cardinality of an empty set is what? Is 0. The cardinality means the number of elements in a what? In a set. And the empty set is a set without an element, so the cardinality is what? 0. Now a finite set is a set whose cardinality is less than what? Infinity. Once the cardinality of a set A is less than infinity, then such set is what? A finite set. An example: if I have a set A, B, C, what's the cardinality of this set? The cardinality of this set, let me call this set B. The cardinality of this set is 3. And 3 is actually less than what? Infinity. So this set is what? A finite set. Okay? Now, since the empty set is a finite set, then the cardinality is what? No, since the cardinality of the empty set is 0, then the set is what? A finite set. Therefore, this means that the empty set, so this implies that the empty set is in what? Is in the algebra. Okay? Secondly, now let A be an element in the what? In the algebra. Now, if A is in an element in the algebra, by definition, this implies that what? Either A is finite or A complement is what? Finite. Okay? Now, if this is so, then this implies that, okay, either A complement is finite. Sorry, my handwriting. Either A complement is finite or A is finite. It's just the same thing. And here I'm saying either A is finite or A complement is what? Finite. So it's the same thing as saying, okay, either A complement is also finite or A is finite. Just like you saying 2 or 3. You can equally say 3 or 2. So they are all the same thing. So either A complement is finite or A is finite. Then what does this implies? Now look at the definition very well. Look at the definition. From here we say that for A to be a subset, for A to be in this set, either A is finite or A complement is finite. Okay, now here we say let A be in the algebra, so either A is finite or A complement is finite. Now we are now having either A complement is finite or A is finite. What does this imply? It implies that A complement is in the algebra. So for something to be in the algebra, that thing must be in the algebra or its complement must be in the algebra. So since A is in the algebra, it is either that A, we're starting with that A, is finite or its complement is finite. But since I'm starting with the complement is finite or A is finite, it means that the A complement is also what? In the algebra. So if A complement is in the algebra, either A complement is finite or A is what? Finite. So we have shown that if A is in the algebra, its complement is in what? In the algebra. So for the third part, now we are going to do some cases here. So we say let A be in this algebra. Okay, we show that A union B is in what? Is in the algebra. Now to show this, we are going to consider the following cases. So let us consider the following cases. Let us consider the following cases. Now remember, we want to show that if AB is in this algebra, then their finite union is in what? The algebra. Now let me give you a hint. Okay, our hint, or what we are about to show, is that for A union B to be in this algebra, it means that A union B is finite, or A union B complement is what? Finite. Once we can show that A union B is finite, or show that A union B complement is finite, whichever of this case, you show that A union B is finite, or A union B complement is finite, then we have now concluded that A union B is in what? In the algebra. Okay, so the first case now, for the first case, remember we said let us consider the following case. So the first case here is going to be when A is finite and B is what? Is finite. Please don't mind my handwriting, please. Okay, now if A is finite, is a finite set, and B is also a finite set, then this implies that A union B is what? Is finite. So if A union B is finite, what does this imply? That A union B is in what? The algebra. Remember, as I said, the hint is to show that A union B is finite, or its complement is what? Finite. Now for the second case, we're going to consider when A is finite and B complement is what? Finite. Now if B complement is finite, this implies that B is what? An infinite set. Okay, remember B is infinite because here we are saying that A is what? A is a subset of what? R. Okay, so if a set B is what? A finite set in R, then the complement of it will be an what? An infinite set. Okay, now this implies that A union B is what? As is infinite. Remember now, this implies that their union is infinite. But remember the hint, we said that either A union B is finite or its complement is finite. So let's check if its complement is finite. Now, when we go for the complement, A union B complement. By De Morgan's rule, this is what? A complement intersects what? B complement. And of course, this is a subset of what? B complement. Now, since B complement is finite, then this intersection is finite. Hence, this is what? Finite. So, this implies that A union B is in what? Is in the algebra. Now, please recall that if I have A intersect B, this is just set theory. Now, this intersection is a subset of A, or this intersection is a subset of what? B. So, of course, this intersection is a subset of what? B complement. And since B complement is finite, this is the bigger one, this is the smaller one. Since this is inside this, then it means that this is what? Finite, and therefore it complements the complement of this union is what? Finite. Hence A, therefore this union is in the what? Is in the algebra. Now for the third case, it's just an opposite of the first one. The third case, we have that A complement is finite, and we have that B is finite. It's just the same thing like this, okay? We have that A complement is finite and B is what? Finite. And of course, if A complement, is finite, if A complement is finite and B is finite, what does this mean? If A complement is finite and B is finite, that means A complement is finite implies that A is what? Infinite. So thus, A union B is what? Infinite. Remember the hint. It's either A union B is finite or the complement of that union is what? Finite. Since this union is infinite, now let's check for the complement. So let's look at the complement. So complement of A union B, according to De Morgan's rule, it is A complement intersect B complement, right? Now, of course, this is a subset of what? A complement. This is a subset of A complement. Now, since A complement is finite, therefore this is what? Finite. So A complement is like the bigger one. Now this is like the A complement as a B complement. So if this is finite, definitely this is also what? Finite. Okay? So since this is finite, then this implies that A union B complement is finite. Hence, A union B is in what? Is in the algebra. So the last case, we are going to consider the last case. The last case is when A complement is finite and B complement is also what? Finite. Okay? Now, if A complement is finite and B complement is finite, it means that A is infinite. A is infinite because if A complement is finite, then A is infinite. Please, I'm sorry for this. Infinite. And B is also infinite because if A is finite, then if A complement is finite, then A is infinite. Then if B complement is finite, then B is what? An infinite set in R, right? Now, this implies that A union B, this implies that A union B is what? Is infinite. Okay, because if A is infinite and B is infinite, then their union will also form a what? An infinite set. But let's check, because we have seen that their union is infinite, let's check if their complement is going to be finite. So of course, A union B complement, of course, we know that this is going to give us A complement intersect B complement by De Morgan's rule, right? Now, of course, A complement is finite, B complement is finite, and the finite intersection of a finite set is what? Finite. Now, finite intersection in the sense that this is 1, this is 2. So, finite intersection of a finite set. The finite set is A complement and the another finite set is what? B complement. So, finite intersection of a finite set is what? Is finite. So, definitely. So, therefore, this means that A union B complement is what? Is finite. Hence, A union B is in what? Is in the algebra. So with all the following cases, we have shown that the union of these two sets is in the algebra. Hence, this is an what? An algebra. Okay? Now, let's also consider another example, a nice example here. Let's say gamma, let's call this gamma, is the collection of all open intervals of R. All open intervals of R. So gamma is the collection of all open intervals of R. We want to show, now the question is this an algebra? Of course, we want to show that something is an algebra. We have to show that it satisfies the three conditions, right? We have to show that it satisfies the three conditions, the three properties. Now, for the first one, you know that the empty set can be written as A, comma A. This is an open interval. So once it's an open interval, remember the hint here now is for us to show that this satisfies the three condition. The hint is that if we can show, okay, if we can show that a set can be written as an open interval, then definitely that set is inside here. So if an empty set, if you can show that the empty set can be written as an open interval, then the empty set is in this. Then if we show that if we pick a set here and its complement is an open interval, the complement is an open interval, then that set is also what? Inside this. So the empty set can be written as this. So this implies that the empty set is a what? Is in gamma. Okay, now let's go for the second condition. Let's pick an A in this gamma. Okay, of course this is a collection of all open intervals of R. So let me just draw a line. So this is an open interval. Now let me just take a set. Okay, let me pick an interval AB. So let's say A is equal to AB. Now what is the complement of this? What is A complement? Let's see. Remember, A is coming from gamma. We want to check if its complement is coming from gamma. So what's A complement? A complement is everything outside A. That is A complement. A complement. So A complement is minus infinity included to A. Okay, sorry, this is not included. It's not included. This means not included. Union B included to what? Positive infinity. And of course, this implies that A complement is not in what? In gamma. The reason why A complement is not in gamma is that, first of all, this is not an interval. Okay, first of all, this is not an interval. Now, when something is not an interval, it is not even, we are not even, since it's not an interval, then we cannot even say whether it is open or closed. Okay, this is not an interval. Reason, because if I pick any two elements here and I divide it by 2, let's say A plus B divided by 2 is not in what? A complement. Okay, so if we pick any two elements and divide it by 2, the result is not in what? A complement. Okay, so for something to be an interval, let's say for something to be an interval, let us say 2, 3. For this to be an interval, it means that for every value I pick inside this interval, okay, if I pick any two values inside this interval and I divide it by 2, the result must be inside this interval. So that's what makes this an interval. But this is not an interval. And since it's not an interval, we cannot even say if it is what? An open interval or not. So it must first be an interval before we can now discuss, okay, whether is it open or is it closed. So it's not even an interval. Definitely it is not what? Open. And since this is not an interval, definitely A complement is not in what? In gamma. So this shows that this is not what? An algebra. Thank you very much for watching this video. Please do not forget to what? Like and what? Subscribe. Also share to your friends. Thank you.